One is actually called symmetric. A symmetric distribution, okay? That's where the left and right hand sides are roughly mirror images of each other. You know, there's some kind of center. We'll see what the center is. Usually it's going to be the average of the data values. But a symmetric distribution, that's where the left and right hand sides are mirror images of each other. So here we have bell shape, which is actually normal, I think a normal distribution, if I remember correctly. You know, you can see it's roughly, you can see that the left and right hand sides relative to the y-axis, they're roughly mirror images of each other. We also have uniform. I mean, in this case, the center would be somewhere to the right of the y-axis. But if we have some kind of center, hopefully you can see that the left and right hand sides would be mirror images of each other. And then we also have what's called a skewed distribution. That's where the distribution shape is not symmetric, and instead it clusters towards one side. So in this case, the variable we're looking at, the distribution of it, the data values are more clustered towards one side. You know, you can imagine, like, if you looked at scores on an exam and lots of people did really well, you know, got near the top, very few people did badly, there you would have a skewed distribution. Okay? Here we have what's called left skewed, where the data tends to cluster on the right, and right skewed, the data tends to cluster on the left. You actually have what's called a peak, as you can see. Okay? So that's what a skewed distribution is. And again, we can use a histogram to present the distribution of a variable. And that's what we're doing here. Here's another example. This one's symmetric. I know it doesn't look perfectly symmetric, but they just figured, you know what, it's close enough. Because data is not, sometimes the data values don't fit to the above shapes exactly as described. You know, they're not perfect, that is. Sometimes you may have approximations, but they'll say, it's close enough. You know, and that's okay. But this would be a symmetric history. This would be a symmetric distribution. So in other words, whatever the variable is in the background that's giving us back these data values, you know, whatever it is, these are the data values. We say, oh, it's the distribution of it is symmetric. So again, the distribution of a variable, you could think of it as the range and the frequency associated with each output. You know, it's what data, what output, what range of values there are, and and how often each value appears. That kind of thing. And again, lots of data sets out there. You know, if you were to make a histogram of them, if you could, they'll fit certain distributions of they'll have distributions of certain variables. So again, instead of studying each data set individually, you could just say, well, this looks like this distribution. Let's study that. So, all right. Does that make sense to everyone? I mean, let me ask this. Do you have any questions at all? I mean, hopefully, I really hope it's making sense what I'm trying to say. All right. Sometimes with data values, you can have what's called an outlier. That's where those are data values that are very extreme. When it's compared, yeah.
Hi, I don't mean to interrupt. I understand what you're talking about. I'm watching your screen as you share it. I just wanted to let you know, I think the notes that you sent out in the email today are different than the ones you're going over. Specifically, the ones that you sent out today are Chapter 5, Section 1 and 2. I just wanted to let you know, because I know that I go back and use them as reference sometimes when I do the work. But I just want